And I've done that for about the 2 or 3 weeks worth of data, and the high average is 50%. The low average, given the worst case scenario flux, is about 15%, and the low rate flux average. So if you take the low rate of flux, it's 50%. The high rate of flux, it's about 22%, and the worst case scenario, that's 100,000 barrels of oil a day, would be about 15% of the flux being flared off.
And does that translate into cubic feet? Millions of cubic feet?
It does, but I can't remember what the number is. I believe it's on the order of... I will send you the right number because I'm not sure what it is. I can check on my computer, but I think it's around 20 million cubic feet per day that they're flaring off, something like that. You can get it from the... I'm pretty sure they have it posted on the Deepwater Horizon Response website. But I get the numbers. I get an update from the Minerals Management Service too, and I can send you if that number may be wrong, but I think that's about right. 20 million or so cubic feet per day.
Thanks.
Yep.
Do you have any other questions?
Any other questions?
Yes.
Lee?
Almost 3 months on now. Just going back to some of the things we were talking about at the very beginning, but how do you see this affecting life in the Gulf of Mexico at this point?
Well, I think there's still so many things that we don't really know. For example, the food web impacts. Data are just now starting to come in looking at higher trophic levels, higher than microorganisms, so copepods and various other zooplankton, larval crustaceans, and those sorts of things. And I've seen images of blue crab larvae with oil and dispersant. The body's filled with it. They just fluoresce like oil under the microscope. So certainly there's this material is affecting the food web, the oil, by far. The impacts on sea turtles and whales. I'm sure most of you saw, or many of you may have seen the images of the sperm whale just covered with oil that were all over the internet last week. It's undoubtedly having effects on higher trophic levels. We still don't know the open ocean food web impacts, and this is something that we've talked about a lot, and we need more data. And Monty Graham's group at Alabama is looking at zooplankton and trophic transfer of oil, and the crews we have in August, September, Joe Montoya and Tracy Villarreal. Joe's from Georgia Tech, Tracy's from the University of Texas. We're going to be doing food web work on that cruise, a lot of food web work. In fact, one of the goals of doing this transect from Texas across the spill zone to Florida is to try and see how far you can track the impact of the spill on either side, to the east and the west, before the surface current switches in the fall. So we'll have a much better handle on how material is moving through the food web at that point. We have we got some of the particular organic carbon data from the cruise back last week, and from our cruise, and there's certainly an oil signature in the particular organic matter. So the microorganisms, you can clearly see a hydrocarbon signature in that fraction from the deep water. We don't have surface water samples from that cruise, however. But I think those data are going to start to trickle in as other groups work up their numbers.
Do you see any progress toward building a more comprehensive research effort?
No, I don't, unfortunately. It kind of looks to me right now like things are sort of stuck. There's yet to have been kind of a meeting in the minds of the people who are working on this problem. The Hart Research Institute in Houston is holding a meeting on the oil spill to sort of try and focus research efforts later this month. I forget when it is, sometime the week of July 20th or thereabouts. And at that meeting, there'll be EPA, NOAA, BP officials, and a small group of academic scientists to try and just start to coordinate this. But I don't understand how we're as far into this as we are without having some sort of a meeting to coordinate what people are doing. I know that there is a lot of coordination between individual scientific teams. Like I've talked to most of the teams that are out there, and they know what we're doing, and we know what they're doing and what they're going to be looking for. But there's so many different efforts going on, and there just doesn't seem to be a lot of structure to who's doing what and why and how it's all being, coordinated to minimize duplication and make sure that the key measurements are being made everywhere. I don't think they are. Again, methane, it's just not being done for whatever reason.
At some point, I think it was on NPR or something, I heard that you had said that the capping will be like the equivalent of trying to cap an erupting volcano. Is the second capping going to involve the same degree of difficulty, or, is it still, the pressure is very, very high?
Yeah, the pressure is going to be high. The advantage of a bottom kill over a top kill, however, is that you've got at the surface when you're trying to cap it. And again, this is just, I don't pretend to know all the details of this, because I think most of the relevant details haven't been released to the public for good reason. But when you think about, this casing pipe was attached to the Deepwater Horizon. When that rig collapsed, that entire feature just crumbled and cracked and got torn and shredded. So there were at least 3 breaches along the seafloor of the riser pipe. It wasn't just one leaking pipe. There were 3 places that the pipe was ruptured and leaking oil and gas. So putting a cap here, you've still got other breaches that are almost impossible to contain, because it's not like this. You're not just putting a cap here. You've got a crack here and a crack over here. And even if you cap all of these, if there's a little fracture over here and you cap this pressure, what's going to happen here? This part's going to blow out. So going at it from the bottom gives you a much better chance of solving the problem and alleviating the pressure, because one, you've got 2 separate relief wells that are being drilled, and 2, you've got a chance of cutting it off at the source much more so than if you did it from the top. Does that make sense? And it's still very, very difficult. They basically use a magnetically guided drill bit, so the steel casing, the drill bit is attracted towards the steel casing. The engineering behind this is just mind-boggling when you really think about it. And and they're going at it from the side, and it's literally a needle in a haystack when you think about it that way. You're trying to find this thing and hope that you can hit it at the spot where you want to hit it. And you can, it's been done in shallower water. It's just never been done as deep as they're trying to do it now. But that's one of the reasons for doing 2, because you double your chances of actually hitting your target with 2 relief wells. But they still have, it's not going to be straightforward. And the biggest concern I think that everybody shares is whether the casing is intact. Because if you cap it off at the bottom and you can shut off the reservoir flow, you still have to deal with the sandstone, the gas in the sandstone, if the casing is fractured or compromised. And chances are that it is, because I read a report last week that I'm fairly certain it's been confirmed that the blowout preventer, the reason they think it didn't work now is because there wasn't just one steel casing in the blowout preventer, there was 2. So the force of the blowout was so strong that it actually jetted one of the seafloor casings into the casing that was in the blowout preventer. So instead of clamping off 1 pipe, it had to go through 2. And that's part of the reason why they think it didn't work, was because there were these 2 that the pressure had forced a casing up into the blowout preventer. So that means that there's something missing down here potentially. So it's very, very complicated.